Hey guys, let's go ahead and get started with note 6.5 on properties of logarithms, day 2. What we are going to be practicing today is expanding and condensing, and that's exactly what it sounds like. If we're expanding something, we are stretching it out into multiple pieces. If we are condensing something, we are bringing multiple pieces together down to be as small as we can be. So when you think about properties of logs and condensing them or expanding them, just go right back to that root word. Okay, there's a couple different properties that we're going to be using today, and a couple of these are already printed out on your notes. The first one that we're going to be using is the product property, and I'm going to be using highlighters today to help me, since I'm not there, to kind of explain and let you see what I would normally write in different colors. But product property, whenever you see that, I'm going to highlight it in yellow. Well, we think about multiplying as a faster way of adding numbers together. So, for example, if I wanted to do 4 plus 4 plus 4 plus 4, that would give me 16. Well, it's easier just to say 4 times 4, right? So when you think of product property, we are actually taking what we were adding together and multiplying it. Or if we have something that we were multiplying, we want to expand that by adding them together, okay? So product property goes with addition. Now, on the other side of that, whenever we see quotient property, when we think of division, that is because we were subtracting something. So whenever we're going to be working with the quotient property, we're actually going to be subtracting some values. Okay. And then the last one that I have currently listed here is the power property. Now, the power property is when we have an exponent on top of the argument. Okay, because remember it's log-based argument. When I have that property, what I'm going to do is take that value that we have as that exponent on top of the argument, and we are going to move it right in front of the log term. Okay. So those few pieces here, again, product property goes with addition, quotient property goes with subtraction, and power property, we are going to be moving that extra exponent. Now, there's one other property that I want to talk about that is not listed here, but let me go ahead. I wrote this down, so I would suggest that you write it. It is very important that we remember how to convert a radical to a rational. Okay, so a radical to a rational is if I have some value underneath the radical, it has some power, and if they don't give us the power, well, then that means that that power is 1. Okay, and it does have a root, and if they don't write that root is understood to be 2. But I will take this radical term, and I would write it as x to the m over n. I wrote that backwards. N over m, because that should be the power over the root. So let me erase this, please, and let me fix that. So that should be the power over the root. Okay, so anytime that we rewrite these, when we convert these, we are going to look for the power and then write it over the root as a fraction exponent. Now, on the other hand, if you ever see a fraction exponent out front, so if you've seen something like this, then we know also that we are going to end up converting that into a radical. Okay, so when you have something like this out front, we're going to end up with a radical at the end. All right, again, I am going to be using highlighting colors today, pretty much just to help me recognize which property that we are using, product property, quotient property, or power property. Now, when we look at these, there's a big thing that I'm going to be talking about is that they need to have the same log base. Okay, so the base has to be the same in order to condense or expand. Have to have a same base. Now, I am going to be putting symbols in front of all of these. Typically, if the first one's positive, we don't put a symbol in front of them, but I want you to start recognizing the plus or minus symbols that I use. So for numbers 1 through 5, we are going to be expanding these logarithms, which means I am taking one log term and I am converting it into multiple log terms. Okay. So for number 1, we are going to be using the product, quotient, and power properties. And I'm going to be looking to see if there's any product, any multiplying happening. I am going to be looking to see if there's any quotient, any division happening. And then I'm also going to be looking to see if there's any power product happening. Okay. And then if need be, we will definitely look at those radical to rationals when they pop up. Okay, because they will pop up today. All right, so let's go ahead and looking at number 1. I have log base 10. Now, 10 is not something they usually write, so we have to understand that that's a log base 10. I have log base 10, and then in parentheses, I have x, y squared, and z to the 4th. Well, x is being multiplied to y squared, which is being multiplied to z 4th. So that means that all 3 of these have something to do with the product property. Okay. Now with product property, we are going to be adding every time. There will not be any division, so we won't use the quotient property. There are exponents on top of the variables, so we will be using the power property. But I'm just going to do the product property right here. So when I rewrite this in expanded form, I'm going to have to write this term log 3 different times. The first time with x, next time with y squared, and then with z to the 4th. So I will have positive log x has a base of 10. Positive log y squared also has a base of 10, so I don't have to write it. Positive log z to the 4th. And the reason these are all positive is because they were all being multiplied. All right. So now I'm going to look at these and say, okay, well, do I have any quotients? No. Do I have any powers on top? Yep, I do. On top of x, there's a power of 1. However, a power of 1 is understood and we have nothing to do with that. This one has a power of 2. So when I have the power of 2, I am going to replace that in front of the log. Then I've got this power of 4, and I'm going to rewrite it in front of its log. Okay, so just the log that it has itself attached to. So when I write this in my final expanded form, I will have log x plus 2 times log y plus 4 times log z. And that is expanded form. Okay, expanded form only using the product property and the power properties. No quotient property on this one. No division was happening. Okay. All right, that should clear itself up here in a second. All right, so then let's go on to problem number 2. Let's see if I can get that extra box to go away. Not quite yet. All right, so on problem number 2, I am again looking at which properties am I using. Do I see any multiplication happening? Yes, I do. I have 9 being multiplied times x to the 3rd. So there I know that I will be using the product property when I expand it. Do I have any division happening? Yes. I am dividing by 2 and by y, which tells me I'm going to be using the quotient property, which includes some subtraction. There's also a power, which is a power of 3, and I'll get to that after I expand it first. Now this time I have log base 5, so when I write it out, I will have positive log base 5 to the power of 9, positive log base 5 to the power of x to the third. And this time I'm going into the denominator, so this is new. We're going to have negative log base 5 2. And y is also in the denominator, so negative log base 5 of y. All right, now that I've got it in expanded form, I'm going to go back and see if there's anything that is part of the power property. Are there any extra powers on top? 9 only has a power of 1, so don't need that one. Understood. X has a power of 3. That one will move right in front of its log. 2 has a power of 1, which is understood. And y has a power of 1, which is understood. So when I rewrite this, I'm going to go ahead and rewrite it in the sense of everything will pretty much look the same except for that power of 3. Okay, so I will have log 5 of 9. Remember, I don't need to put that positive in front of the first term. Okay, plus 3 times log base 5 of x minus log base 5 of 2 minus log base 5 of y. Okay. Now, when we're simplifying logs, we're going to be thinking about, is there 5 to what power would give me 2? Well, there is no exact value that we can think of. Okay, what power of 5 to what power would give me 9? If there was something, we would replace it with that number, but at this point we're just working on the expanding and condensing. Okay. So that is our expanding log base 5, 9x to the third divided by 2y. Okay. All right, so let's go on to part 3, or question number 3, and see what we are looking at here. Again, if there's any power property, quotient property, product property, and if we have any radicals to rationals. All right, on this one here, log base 6, so that will be my log and my base for every term that I write. It has to be log base 6. Anything with the product property, yes, 7 is being multiplied to x to the fourth. Any quotient property, yes, they're also being divided by w squared and y to the third. So I know that I'm going to write log base 6 4 times. First time with 7. So I have positive log base 6 of 7 and plus log base 6 of x to the fourth. And then now we're going into the denominator, so it's not going to be positive anymore. It's going to be minus log base 6 of w squared minus log base 6 of y to the third. Now, you definitely need to have that base. Without that base, I'm assuming that you're talking about base 10, which we're not. So you've got to keep that base on there. Okay, let's go see if there's anything that is the power rule. Well, 7 does not have an exponent other than 1. X has a power of 4, which we will move in front of its log. W has a power of 2, which we will move in front of its log. Y has a power of 3, which we will move in front of its log. Okay, so let's write this out. So I've got log 6 of 7 plus 4 times log 6 of x minus 2 times log 6 of w and minus 3 times log 6 of y. Okay, that will be that, number 3, in expanded form. And let's go on to problem number 4 and write this one in expanded form. Now on this one here, I can see that it is a radical. Okay, so I'm going to go back to the top because I want to talk about this for a second. Every time that I've looked at these, I've looked to see if there was power property, which every one of these has had power property. After power property, I went and said, is there quotient property? And if there was not quotient property, I skipped over that and said, is there any product property? Okay, so I went here, power, quotient, product. And then now we're also including converting radical to rationals. Okay, so let's go back and let's look at that one. First on this though, I need to convert that radical into a rational. I need to get rid of that radical symbol. So to do that, log base 10. So I have log base 10. I'm going to take what's underneath the radical and put it in parentheses. X and then y squared, just the y is being squared, to the power of 1/5. Now what I'm going to do is I'm going to take that 1/5 and I'm going to distribute it to each of the exponents or the powers on the inside. So 1/5 times 1 and 1/5 times 2. Okay. So when I write that, I will have log base 10 of x to the 1/5 and y 1/5 times 2 gives me 2/5. Okay, so when you get better at this, you'll see how you can do 2 steps at once, but right now I'm only going to focus on 1 step at a time. So I'm going to distribute that 1/5 to each of the power on the inside of the parentheses. Now I'm going to go ahead and write this in expanded form. So they have log base 10, and they're both being multiplied. Okay, x times y squared, or here, x to the 1/5 times y to the 2/5. So I'm going to go ahead and write that in expanded form. So I have log base 10 x to the 1/5 plus log base 10 y to the 2/5. Now I'm going to go look for the power rule. Are there any powers? Yep, 1/5 is a power. So that 1/5 is going to go in front of that log. 2/5 is a power. So 2/5 is going to go in front of that log. Okay. So we have 1/5 times log base x plus 2/5 times log base y. And that is our expanded form on that one. Okay. And I thought there was 5 of these, but there's only 4. So we've got 4 on expanding, and now we're going to go to condensing. Okay. So when we're looking at condensing, we're going to take what's already pulled apart, and we're going to condense it down into 1 log. Right. So we're going to be looking at these steps. Again, looking at them all, seeing if there's any power product property, product property, quotient property, power property, and even considering if we have to turn conversions between radical and rational. Okay. All right. Number 5, write as a single logarithm, we are going to condense it. Okay. So first off, they will have the same base. When we're condensing, they will have to have the same base. Well, I'm looking at these. They both have log base 7. So I know that I can condense these. Okay. Now, do we have anything positive? Do we have anything negative? So let's look at those then. Well, the first term is a positive term. So since it's a positive term, I know this is going to go in the numerator. Then I have log 7 of 3, but that's a negative term, which means I know this is going to go in the denominator. Okay, so log base 7 of 12 and negative log base 7 of 3. So when we write this in one term, log base 7, this is always, right now when we're condensing it, it'll always be just a positive log. I know there's going to be a fraction. 12 is in the numerator. 3 is in the denominator. And when I simplify this, I've got log base 7. 12 divided by 3 is 4. Is there anything that's 7 to any power to give me 4? Nope. So that is condensing it. Okay. Taking multiple logs and bringing them together to be 1. All right. Okay. Let's go on to number 6. Again, making sure that they all have the same base, and they all do. They all have log base 10. Now, I have a power rule going on here, so I want to eliminate that first, or move that first. So I've got this 2 in front of the log. That 2 is going to be the power on top of 3. Log to the 4 has a power of 1. We don't need to worry about that because it's understood. Log 12 has a power of negative 1, but 1 is understood. So let's write this with 3 to the second power. So I will have log base 10 of 3 to the second power plus log base 10 of 4 minus log base 10 of 12. Okay. All right, 3 squared, that'll be a numerator because there's a positive up here. And 4 will be in the numerator. And then 12 will be our value in the denominator. So we'll rewrite this with the same base. So log base 10 in the numerator, 3 squared makes 9. 4, and in the denominator, 12. When I simplify this, I have log base 36 of 12. And 36 divided by 12. So then I have log base 10 of 3. Okay. All right. Okay, let's go on to problem number 7. All right, on problem number 7, first thing we are looking at again is I see that I have a power up front that is going to go on top of the x. So it'll be x to the 1/2 power. Now, remember I said if we have a fraction value out front, that means we are going to be turning this into a radical before we're done. Okay, here's power. So it'll be y to the 3rd power, and it will be z to the 5th power. We don't take the sign, we just take that a value because we want our powers to be positive. They can't be negative. All right, so let's go ahead on this one. If I rewrite it, I will have log x to the 1/2 power minus log y to the 3rd power minus log z to the 5th power. X to the 1/2 power, that is a positive log term, so that'll go in the numerator. y to the third is part of a negative log term, so that'll go in the denominator. And z to the fifth is part of a negative log term, so that will also go into the denominator. So when I write this out, I have log, so a single log because we're condensing it. In the numerator, I have x to the 1/2, but we are going to be rewriting that in radical form. So I will have x underneath the radical. The power is 1. The root is 2. Now, I don't write 1 as a power and I don't write 2 as a root because they are understood. However, if you need to write them, go ahead and write 1 x to the first power and 2 for the root. The negative log term y to the third goes in the denominator. Negative log z to the fifth and z to the fifth goes in the denominator. So taking 3 log terms and condensing them into 1 log term. Okay. All right, problem number 8. On problem number 8, now there's a couple of things here. First off, I noticed that I have a couple powers. I have 1/3. Again, there's that fraction, so that means it's going to be turning into a radical. It'll be x to the 1/3. I also know that I have 2 here. So 2 will be w squared, right? Nothing in front of log 4 to the y, log base 4y. So what I wanted to point out is there is a negative sign right here. That negative gets distributed to everything following it. So this would be a negative 2, and this would be a negative log. Okay, so even though this one has a plus in front of it, a negative times a positive will make it a negative. Okay, all right, so let's go ahead and let's go write it out first off, moving those power rules to the backside, so that I will have log base 4 of x to the 1/3 power minus 2, nope, I just said I wasn't going to do that, minus log base 4 of w to the power of 2 minus, because I'm distributing that negative, log 4 of y. Okay, now that I've moved the powers over, addressing that power rule, now I'm going to go ahead and write it as one term. They all have log base 4. So I have log base 4 written only once because we are condensing it. There's some positive terms and some negative terms, so I know I'm going to have a fraction. X to the 1/3 is part of a positive log term, so that's going to go in the numerator. And I'm going to write it as a radical. X to the 1/3. Okay, so third root. X to the third root. Then, negative log to the 4th w squared. So w squared goes in the denominator. Negative log 4y. And y goes in the denominator. That is our condensed log. Okay. All right. We've got 2 more that we are working on. Okay, on number 9, this one here, we are going to simplify this. So we've got to remember some of our factoring skills. How do you factor x squared minus 36? Or what 2 numbers multiply to negative 36 but add to 0 because there's no b value? So when I write this in expanded form for number 9, I will have log base 4, x plus 6, x minus 6, minus log base 4 of x plus 6. All right, log base 4 of x plus 6 and x minus 6. This is all part of the positive log term. So this is all going to go in the numerator. Okay, again, because this is a positive. All right, now looking at negative log 4 x to the plus x plus 6. This is going to go in the denominator because it's got a negative in front of the log value, log term. All right, so when I write this in condensed form, I know that log base 4 is what I'm looking for. In the numerator, I will have x plus 6 and x minus 6, which are the factors of x squared minus 36. In the denominator, I will have x plus 6. Looking at this, is there anything we can simplify from the numerator and denominator? Yes, these two here will reduce to 1. So we are left with log base 4 of x minus 6. All right, and on to our last one, which is number 10. Okay, on this one here, I have log base 9 plus 3 log 2 minus log 3. Right? So I have power of 3 that'll go on top of 2. Log 9 is positive. 2 to the third power will be positive. And negative log 3, that'll be negative. So I know I'm going to have a fraction. So I will have log base 10 of 9 times 2 to the third power over 3. So that'll give me log 9 times 8 over 3. Rewrite it again. So I have log of 72 divided by 3. And finally, that simplifies to log base 10 of 24. Okay. All right, so that is ours on expanding, taking one log and making it multiple logs, or condensing, taking multiple logs and converting it into one log. Okay, looking at those properties. Now, your homework is 6.5 properties of logarithms. There's some matching, there's some condensing, and some expanding. This one is due by this evening. After 8:30 tomorrow morning, you will not be able to turn it into Canvas. So make sure that you complete this and get that turned in, please.